This is exam number 3 for Math 4150, question 1. We're supposed to complete the table below regarding octagonal, decagonal, and pegonal numbers. And we have hexagonal numbers as a sample. So to figure out the first 4 stages of octagonal, I counted down here and got 1, 8, 21, and 40. I saw that there was a pattern of adding 6 to each number that is added each time. So between 1 and 8 is 7, and then between 8 and 21 is 13, and 13 minus 7 is 6. And so I got these numbers for the octagonal row. And then for the equation, I got n times 3n minus 2. So for example, 3 times 3 minus 2, which is 9 minus 2 is 7, times 3 is 21. And you can plug that n into any number. N can be any number, and you can use this equation. For decagonal, I use this down below also as a starting point, and got 1, 10, 27, so on. And notice that there's a difference of 8. Like in the last one it was 6, this one's 8, which tells me that if you subtract 2 from the number of vertices, then that should be the difference between the numbers that you are adding each time. And then for pegonal, I notice you're always going to have 1, and then P is always going to be your second stage, and then you're going to times it by 2 in the next stage, and then you have to subtract the dots that they already share, and then you have to also add the previous number of dots that you got. So down the line you go 2 times 3, 3 times 3, 4 pi. So if these go up by 1s, these go up by 2s being odd numbers each time. And then these are just adding the one from the previous one. For question 2, we were asked to show where the park could possibly be located using Euclidean and taxicab geometry. Starting with Euclidean, we know that we do not have to stay in the lines and only turn at intersections. So if we do 4 on each side, we get 4 by 4 square. And we can use the Pythagorean theorem to find this distance right here, knowing since we can go through the squares. So 4 by 4 is 16 plus 16 equals 32. So if we take the square root of 32, we know this whole line is 5.66. Now to find a spot that is equidistant from Poly-Eyes and the gas station, we'll go to the middle of this line, which would be 2.83 blocks away from the Poly-Eyes and gas station. It means for Euclidean geometry, the park could be here. For taxicab, we know we have to stay on the roads and only turn at intersections. So this one, we will look, and you can we will make these taxicab circles going 4 at each point, 4 away from Poly-Eyes and 4 away from the gas station. And we can see this square where they or this line where they kind of overlap. So we know that the park can be here or here because at this point it's 4 away from Poly-Eyes and 4 away from the gas station. And it's the same here as well, 4 away from Poly-Eyes and 4 away from the gas station. The third part, it asks us to move the gas station to an intersection such that the park will not exist in taxicab geometry. So the gas station was right here. We know we need to move it to a place where the distance between the gas station and Poly-Eyes will be odd. So I moved the gas station here, and it makes the distance 1, 2, 3, 4, 5, 6, 7 on both sides from the gas station to Poly-Eyes, which means that on either side, the park would have to be located 3.5 squares away from both places, which means the park could not exist because it would be in the middle of a line and not at an intersection. This is question number 3 for exam 3. So this gives us a map of water and a boat to a treasure chest, and it asks us, how far is it from your yacht to the treasure using Euclidean geometry? So using Euclidean geometry first, we can go across and we don't need to stay on the lines or the intersections. So since this diagonal line will be in it, we can use the Pythagorean theorem to find how many miles it is. So if you take 9 squared plus 17 squared, it will give us c squared. So 81 plus 289 is 370, and 370, the square root of 370 is 19.24. Next, it asks us how far is it from your yacht to the treasure using taxicab geometry. Well, for taxicab, we have to stay on the lines and on the intersections. So we can take the most outer line to find how many spaces it will take to get there in the quickest, probably the quickest way. So we can start from this way or go this way, but we don't need to use this space or this space because we don't want to go down and we don't want to go to the right because then we'll be backtracking. So we find that there's 26 spaces to the treasure using taxicab geometry. The last part says if you're only allowed to travel on grid lines and turn at intersections, how many different paths are there to get to the treasure? This is one that takes a bit longer to do. The basic principle is we have ones on this side and ones on this side, and then to get the next number you add the other two corners. So to get this, you add this corner and so on. And I have made a little guide. Whatever number is in the box, it goes to the top right corner. And that's a basic principle, but the thing that we have to remember is once we get up here, it's going to say 28 all along this line. Because once we get here, we can't go up, we can't go down, we can't go left. So we can't come from here, and we can't come from like here because we'd be backtracking. So all along this line is going to stay 28. And it's the same for this line and then this small line. And the final number after you add all these together is 2,012,332.